Okay. So if this is increasing here, it's also increasing here and here, right? So if I ask the intervals on which it's increasing, well, I'm talking about not the y values, but the x values. So the x value that it starts increasing is at 0, and it ends at 2. So the first interval that it's increasing is 0 to 2. Does that make sense? From 0 to 2 is where it's increasing. God bless you, sir. Oh, ma'am. What's the next interval that it's increasing? Someone raise your hand. Well, it's not increasing the entire time from 0 to 6. Yes, ma'am? 4 to 6. Good job. 4 to 6. From 4 to 6. And so since there are two intervals, I write a U here. And U means union, which means it's including this set as well. 4 to 6. And I have a third interval. Someone raise your hand. Yes, ma'am? Good job. Nicely done. Union 8 to 10. And that's it. Any other intervals where it's increasing? No? Okay. Next, decreasing. Decreasing means it has a what kind of slope, class? Negative. So it's decreasing here, here, and here. So it's decreasing on the intervals. The first interval that it's decreasing, yes ma'am? 2 to 4. Good job. And the next interval, anybody? Yes ma'am? Go. 6 to 8. Good job. And the next interval, yes ma'am? 10 to 11. Can you guys see that? Is that clear to everyone? Is there any questions on that? Any questions on these intervals? No? Okay. All right, good. All right. Next. We've done increasing and decreasing. Now we're going to do average rate of change. Now, class, who can tell me, by raising your hands, what's another way, or actually just whole class, go ahead. What's another way to talk about rate of change? It's one word, begins with an S. Class? Slope. Yes, I'm getting excited. Slope. Okay, so if I'm talking about slope, what's the formula to determine the slope? Someone raise your hand. Yes, ma'am. Y equals mx plus b. Yes, you got the right idea. You're on the right direction. Mr. Williams, go ahead. Rise over run. Who's got the formula? Yes, ma'am.
y2 minus y1 over x2 minus x1.
There you go. That's what I'm talking about. The slope m is y2 minus y1 over x2 minus x1. Okay? And so if I'm talking about a specific interval, which it is giving me, what's the given function's average rate of change on the interval 0 to 2? Which points should I use to determine my interval? To find my rate of change, which points should I use? I got to use 2 points, right? Yes, sir?
0, negative 1, and the point that's 2.
Yep, and 2, 1. Good. Why did you use those points, Mr.
Well, first of
Chimango?
all, the inequality is starts on the x-intercept because you're basically writing like the point, so it starts on the x-intercept with the 0, and then it's greater than or equal to the x, which is greater than or equal to the next exit y-intercept. So there's 2 y-intercepts there, so you pick each one.
Okay. You have the right idea. It's the explanation is a little bit, and I'll try and help you out. See if we're on the same page. The interval, I got you. Good job, sir. The interval is from what to what, Mr. Trelongo?
Is from 0 to 2.
Right. And so I should use the points at the ends of the interval, right? Good. Nice. So I use the points at the ends of the interval. If I want to find the average rate of change, I have to use the points on the end of the interval. Okay? So this first point here is 0, -1. And the second point here is 2, 1. Okay? So if I use this as my x1, y1, and class, we got to be careful. This is not x1, x2. This is x1, x1, y1, and this is x2, y2. You see? Yes, ma'am?
Is that supposed to be a 6 or a 0?
Where?
Oh.
Oh, that's a parentheses, sorry. It's a little weird. The program kind of makes my handwriting look worse than it is. I promise I don't write like this in real life. That would be kind of embarrassing, but it's okay. All right, so y2 minus y1. y2 is 1. y1 is -1, so it's 1 minus -1 all over x2 is 2 minus x1 is 0. Okay, 1 minus -1 is 1 plus 1, which is 2 over 2 equals 1. So the average rate of change on that interval is 1. Does that make sense? Basically, you just find the slope on the interval. Okay, the average rate of change on that interval. Okay, you do that by finding the point at the beginning of the interval and the point at the end of the interval, and you find the slope for the line that connects those 2 points. Any questions? Yes, sir.
On like testing quizzes and stuff, when I write this kind of stuff, and there's a negative value, and then like after the negative sign, I'll just put a plus because they cancel out. And say your teacher grading work, would you perhaps mark off that?
No, unless you made a mistake.
Okay.
So if it actually was 1 minus 1 and you put 1 plus 1 because you were kind of going fast, then to me what that shows me is I can't tell that you knew in your head potentially what. So you see, you can actually lose out on some partial credit by skipping that step. But if you're confident in it and you just know what you're doing, then no, I'm not going to take off points. The only time I would ever take off points is if you end up with the wrong answer. And then if you have the right answer, generally speaking, I'm looking at your work just to make sure you didn't just come out with the answer out of nothing, out of thin air. But if you got the wrong answer, that's when partial credit comes into play, right? Does that make sense? Okay. All right, next. Any more questions on this? No? Okay. All right. Next, we're going to learn about maximum values and minimum values. So, a maximum value is where a function changes from increasing to decreasing. Okay? And so, if I look here, a maximum value, it goes from increasing to decreasing. Well, here's increasing, then decreasing, so there's a maximum value. Increasing, decreasing, there's a maximum value. Increasing, decreasing, there's a maximum value. You see? Does this make sense? Now it says, how many points does the function change from increasing to decreasing? 3. I just erased the 3 to write it again. Okay? And then the next page, it says, what's the value of the function? What's the value of the function at those points? If I'm asking the value of the function, what does that mean? The x values or the y values? Class? Y values. So what are the y values at those points? 1. They're all 1. So the answer to that is simply 1. Next we learn about minimum values. Where a function changes from decreasing to increasing is called a minimum value. So here, it's just increasing, then decreasing, then increasing. So decreasing to increasing, and then decreasing to increasing. Why didn't I highlight the 2 points on the end, class? It didn't go from like decreasing to increasing there. You see? Does that make sense? Okay. So those are my minimums. How many points are there? Clearly 1, 2. And what is the function's value at these points, class? -1, right? Here we are at -1. Any questions on that? Any questions on that at all? No? Okay. Good. All right, so continuing on, last thing we're going to learn about in this part is zeros. The zeros are of a function are where the function is equal to what, class? What would you think? 0. Very good. The zeros of a function are where the function is equal to 0. It's also known as the blank intercepts. What goes in the blank, class? X. The function is equal to 0 at the x-intercepts, where the function intersects the x-axis. So the zeros are here, 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 and here. You see? The function's value is equal to 0 at those points. Okay. Question is, how many x-intercepts does the given function have? How many zeros? 1, 2, 3, 4, 5, 6. And identify the zeros of the function. If I'm identifying the zeros, do I care about the y values? No, right? What are the y values of every 0? 0. So it would be redundant, right? So we say we care about the x values, which are 1, 3, 5, 7, 9, and 11. So the zeros of the function are the set 1, 3, 5, 7, 9, and 11. Does that make sense? Okay, any questions on that? No, you could also write it as x equals 1, 3, 5, 7, 9, and 11. But if you just wrote 1, 3, 5, 7, 9, and 11, I would call it a question. It'd be hard for me to give full credit for that. Okay? Any questions on this? No? Good? You guys are like acing this right now. You're just like, psh, I got this. Okay, next. Sketching a function's graph from a verbal description. Okay, the point is, if I give you a verbal description of something, you should be able to sketch a graph of it. So the first thing you want to do is identify what the graph is on. Here it's probability of transmission from an infected tick. That's nice. Time a tick is attached to your skin. You guys know what happens when a tick bites you? You know what happens? Has anyone ever gotten bitten by a tick in this class? You have? You have? What was it like?
I don't know. All I know is that I was just walking through the woods in Massachusetts. Like I like full on one day. There were deer ticks though, so you can see them. But it doesn't hurt, and it doesn't even hurt when you remove them. It just like they're just kind of there. I guess.
Yeah, interesting. Yeah, and
It hurt when I removed mine.
yeah, maybe it might have been in your skin for a little bit longer. What happened with you? You were walking through like the woods or something like that?
Yeah, I was in a spring in Gainesville, and I guess I got ticks on my back or whatever.
Oh wow.
I was camping, and we were walking back, like, from the spring, I guess, and then we went through the woods to our campsite, so I guess that's how it got on me.
Interesting. Well, that's good. You got to be careful because ticks can give you Lyme disease, and this what this graph is showing you that like if you leave a tick on your skin for a day, which like God willing that never happens, but like if you just don't see it for whatever reason, like it's fine for the first day, but by the second day you have a 10% chance of getting Lyme disease. By the third day, you have like a 75% chance. If you leave a tick on your skin for like 1, 2, 3, 4, 5 days, then it's like basically 100% chance. At least that's what this graph is saying. I don't know if that's 100% accurate, but to me that's enough. Like I'm not leaving. Like if I see a tick, I'm not gonna be like, oh, you could just hang out for a little while. Like no, just pull it out or burn it or something. I don't know.
Your ticks are the only ones that get one disease.
Are they?
Super small ones that you can barely see.
Really? Oh, okay. Well, hey, just if you guys go in the woods, check for ticks when you get out. Don't mean to scare you, but anyway. So the point is you figure out what the graph is about, you figure out what the axes are telling you and what the scale of the axes are, and then you go ahead and graph. So I think this is pretty self-explanatory, so go ahead and do number 4 on the top of page 20. And I'll give you a couple of minutes to do that. Go ahead and do number 4 on the top of page 20. First thing you want to do is figure out what the graph is on, and then go ahead and read the question. We have 30 seconds, and we'll do it together. Anyone have any questions? Want to come over and help? Have you ever seen this before? Sorry, that's wrong. You guys are hard to work. It's a braille machine. You've seen that before? It's a braille machine. I've never seen this in my life. It says Perkins Brailer. That's so cool. I'm sorry. I'm sorry. That's just really cool. I've just never seen that before in my life. I have no idea how to work it. That's cool. All right. All right, the graph is showing strawberries on the shelves. Not the strawberries being sold, the strawberries on the shelves. Okay, time since opening in hours. At time t equals 0, what does that mean in real life? T equals 0. In this situation, what does that mean? Store is closed and it's the hour it opens. Very good. Okay, so and then we have cartons of strawberries on the shelves here. Okay, so it has. So we start, grocery store stock shelves with 100 cartons of strawberries before the store opens. That means at t equals 0, we are at 100. For the first 3 hours the store is open, the store sells 20 cartons per hour. Okay, so then after an hour I go down 20 and I'm at 80. Another 20, I'm at 60. Another 20, I'm at 40. So for 3 hours. Over the next 2 hours, no cartons of strawberries are sold. So 2 hours stays at 40. The store then restocks 10 cartons each hour for the next 2 hours. So 10, and then another 10. In the final hour that the store is open, 30 cartons are sold. So it goes down 30. Okay? And you should have gotten something like this for your graph. Any questions on that? No? Kind of thing that you guys have done before, certainly. Okay, let's move forward. Any questions? You guys copying it down still? No? Good. Okay. Feel free. The only time I'm like kind of okay with you guys calling out is if you just like wait. It's okay. I'll wait for you. All right. The next thing I want to do is do a scatter plot with you guys. So go ahead. This is actually part of your homework. It's number 14 on your homework. So we're going to start your homework together. Page 26. So sometimes when you have data, you want to create a scatter plot so you can show it in a way that makes sense, so you can see if there's any kind of relationship. Here we have planes. We have the length of the plane and the wingspan of the plane. And so we're going to make a scatter plot with all the data that we have. So we'll do it together. The first one, the length is 130, the wingspan is 113. So if we look at this, here's airplane length in feet, wingspan in feet. They both go up 20 with each tick, right? Hot tick. All right, 113. The length is 130, and the wingspan is 113. So it's 130, 113 is about here. Okay. Next is 148 and 108, which is about here. Next one is 155 and 124, which is about here. Next one is 178 and 147, which is somewhere close to here. Next one is 180 and 156, which is basically here. The next one is 209 and 200, which is right here. Now, once I've plotted those points, I want to create a line of best fit. Okay? So line of fit, let's talk about it here. Line of fit. Who thinks that's a good line of fit? Raise your hand. Okay? Who thinks that's a good line of fit? Raise your hand. No one. Okay, I'm going to sketch 3 lines of fit. I'm going to do this one here, the blue one. I'll do this one here, the green one, and I'll do this one here, the red one. Okay. Raise your hand if you think the blue line is the best line of fit. Raise your hand if you think the green line is the best line of fit. Raise your hand if you think the red line is the best line of fit. Very good. Okay, so we understand what a line of fit is. Nice. So we've got our line of fit here. Now it says use the line of fit to predict the wingspan of an airplane with a length of 220 feet. So what I'm going to do is I'm going to go ahead and find 220 feet as a length, which is here. Find the intersection with the wingspan, which is here. And so what it seems that I've found is that for a 220-foot plane, the wingspan will be something like 210 feet. Is that pretty clear? Does that look good? You understand how we use this data and then a line of fit to predict things that we don't necessarily know? Any questions on this? Good? All right. Nice. Okay, so with that being said, you guys have about 7 minutes to start your homework. Your homework is lesson 1.2 up to number 15, 1 through 15. Okay, and also you should watch the videos, right? We just learned lesson 1.2 today, so you're going to go home and watch the lesson 1.3 videos.
Starting on page 24.
Starting on page 24, exactly.
Okay.
1 through 15. Yeah, and if you have your syllabi, your syllabus, I will collect that now. Thank you. Remember, you have until tomorrow to get that incident. Anybody else? All right. Any other questions? Okay.